What is the world made of? In trying to answer that question, philosophers and scientists for thousands of years have been considering everything from the smallest particles in the universe to cataclysmic events happening billions of miles away.
This is where the commonest elements are created in stars, like our sun. Stars are made largely of hydrogen, but when hydrogen atoms are superheated, they fuse together to make heavier elements, from helium up to elements as heavy as iron.
Stars are like ovens. The longer you cook the elements of a star, the more elements you make. But our sun is not hot enough. It doesn't have enough energy to combine elements to create elements beyond iron. However, our bodies, of course, are made out of elements like cobalt and nickel that are beyond iron. So we had a paradox. Where do we have enough energy, raw energy, to create the elements beyond iron? And the answer is supernovae. When stars explode, trillions of degrees are attained. Temperature is so hot that you can slam iron and different elements together to create uranium, to create plutonium, and all the other elements of the periodic chart. So when you look at your body, when you look at the elements around yourself, just realize that we are made out of stardust. We came from the stars.
It took centuries to discover those elements and sort them into a neat periodic table. But people have always been fascinated by what the world around them was made of.
Sitting here on the beach, gazing into the fire, takes me straight back more than 2,000 years to ancient Sicily and a chap called Empedocles, who sat and gazed into his fire and thought about the world and came to the conclusion it was made of just 4 elements: earth, air, fire, and water. He could see them all there in the fire. A piece of green wood going on dribbled sap. It was obviously the water trying to get back to its natural home, the sea. He could see the smoke rising up to its natural home, the air, the flames rising up to their natural home, the fire of the sun, and of course the ash became part of the earth. The whole thing was made of just the 4 elements: earth, air, fire, and water.
Today, we see things differently. Pure water consists of 2 chemical elements, hydrogen and oxygen. If we analyse Earth, we find that it contains dozens of elements. But centuries ago, people had already isolated some of the elements we recognise today. They smelted metals like lead, copper, iron and tin, using charcoal, a form of carbon, to fuel their fires. And they were particularly fascinated by gold. Early scientists spent 2,000 years trying to make this precious element from less valuable materials. More like wizards than true scientists, they were known as the alchemists.
Mix the yolk of eggs with the grindings of their shells. Pour the mixture into a sealed container and burn for 41 days. Boil the residue with water. Then put the solution into a container and cook for 2 more days. Empty the contents onto a conch shell, smooth them out and expose to the sun. The water will thicken into a soapy substance. Melt 1 ounce of silver, add it to the mixture, and you will have gold. This recipe comes from Zosimos of Panopolis, who lived in Alexandria about AD 300. Another alchemist suggested feeding particles of gold leaf to chickens in the hope that they'd lay golden eggs. Of course, these recipes didn't work. You can't make gold like that. Nevertheless, they kept Zosimos and his fellow alchemists busy for a very long time. But some alchemists did make some real discoveries while conducting some seriously weird experiments. In 1669, a German called Hennig Brandt began experimenting with urine. Now, alchemists loved urine. They called it the golden stream, and they loved it because it was the right sort of colour, although not the right sort of smell. Anyway, Brandt collected 50 buckets of this stuff. He
He stored it until all the liquid had evaporated and all that was left was some sludge and a lot of wriggling worms. Oh.
That was not all. He then boiled the stuff up and allowed it to ferment till it turned black. He added some sand and heated the whole lot up in a retort. Fumes started to appear in the glass. And then something very strange came to pass.
He had in his flask this wonderful, mysterious substance that glowed in the dark. Before his eyes, it flickered and flamed. He thought it would go out, but it went on and on. What he'd actually discovered was phosphorus. He didn't know it was an element. In fact, he had no idea what an element was. He called it cold fire. A contemporary of that alchemist was an Irishman called Robert Boyle. He dabbled in alchemy himself, but he was much more scientific because he based his conclusions on experiments and not just on mumbo-jumbo. It was Robert Boyle who defined an element. He said that elements can combine together to form compounds, but they cannot be separated into simpler substances. Now, I've got some elements here. This is silicon. These are metals. This is bismuth, beautiful cubic crystals. Here we've got sulfur. It usually comes as powder and this has been compressed into a rod, but here are some beautiful crystals, natural crystals of sulfur. This is iodine. You may be able to see the pale mauve vapor and lovely, lovely purple crystals up here on the wall of the glass. This is bromine, another of the halogens. You see it's got liquid in the bottom and vapor above, deep brown, very heavy liquid. And this is chlorine, a greenish yellow gas, very poisonous and unpleasant. So back in the 17th century when Boyle was working, they had very few elements at their disposal. It wasn't really till the beginning of the 19th century, the early 1800s, that they could lay their hands on a whole lot more. And quite a lot of those were the result of their having at their disposal a new and powerful tool, electricity.
By passing a strong current through caustic soda, Humphrey Davy first extracted sodium in 1807. It was hazardous work. When we reconstructed his experiment with modern equipment, the voltage regulator blew up.
Well, Humphrey Davy, in fact, prepared 4 new elements using electrolysis. First, potassium and sodium, and then he went on to make barium and strontium by essentially the same method.
19th century scientists found out everything they could about elements and their compounds. They knew that some chemical reactions were activated by catalysts. For each element they recorded the melting point, the boiling point, how it reacted with other elements. They calculated the atomic weight, which we now call atomic mass. They knew that elements had electrical properties that encouraged them to combine. Sodium burns in chlorine with an orange glow to make salt, which is that white, smoky stuff. After centuries of struggling in the dark, they had a mass of data, but it was confusing, and inquisitive scientists began to wonder whether there was a pattern in all these findings.
By the middle of the 19th century, chemists had got hold of about 50 or 60 elements, but they didn't quite understand their relationship one with another. However, some patterns were beginning to emerge. Mike, what have you got for us here?
I've got a metal called lithium.
One group of elements, the alkali metals, all react with water.
It's a bit feeble, isn't it, Mike?
It is, yes. A little bit like Alka-Seltzer.
Yes, absolutely.
But as you go through the group, the reactions become rather more vigorous.
Okay, so it's sodium now, is it?
Yes, indeed. Potassium.
It goes with a bit of a bang.
It does, doesn't it? Yes.
Lithium, sodium and potassium clearly formed a group of similar elements. The halogens, chlorine, bromine and iodine, were another group. There were obviously patterns in the elements, but no one could come up with a single pattern which linked all the elements together.
One of the reasons for this was that at the time many elements hadn't been discovered. So that although they didn't know it, they were trying to complete a jigsaw puzzle when many of the pieces were missing. They were convinced that buried in all that data there was some sort of pattern, but to find it was going to take a lot of time and patience.
One of those who set about the task was a Russian, Dmitri Mendeleev.
Dmitri Mendeleev had a very strange history. You see, he came from Siberia, the backwash of the Tsarist Empire, and he was the last of 17 children. And as a consequence, his family lived in total poverty. In fact, his father went blind and eventually died, leaving his family in tremendous poverty. And then his mother, in one of the great stories of self-sacrifice, his mother basically gave up her life to make sure that her youngest son had an education.
His mother uprooted the entire family and took him to St. Petersburg, where she tried to persuade local universities to take him and train him.
Well, of course they said no. He's from Siberia, the backwash. And yet, just before she died, she was finally able to get her son into one of the academies that then launched his great scientific career.
As a young man, Mendeleev became famous for his quick mind and quick temper. He was impatient and very argumentative.
He was very driven, he was very determined to do what he set out to do. He was very stubborn.
He also became rather eccentric. He grew a long beard and hardly ever cut his hair, but he was totally dedicated to his work.
Mendeleev knew everything there was to be known about the 63 elements then discovered, and he was determined to find out about their relationship with one another. And when Dmitri Mendeleev made up his mind to do something, he didn't give up until he was fit to drop.
Though he was a very impatient man, he used to calm himself down by playing patience. The aim of the game is to sort all the cards into the right order and the right suits, which was not so very different from what he was trying to do with the elements. Mendeleev took a sheaf of blank cards and wrote down the names of all the 63 known elements, together with their atomic weights. He began puzzling over his cards, trying to see if he could place them in groups. But try as he might, he could not find a pattern. He was due to leave on a long journey, but he told his driver to wait. He puzzled over his cards a few hours longer.
Господин, пора ехать.
He sent his driver away. Shuffling the cards around the table, he felt sure that he was on the brink of a breakthrough. But after hours of struggle, exhausted, he fell asleep. He began to dream.
Натрий, бром, цинк, алюминий, никель, кобальт,
The halogens.
молибден,
And as he dreamt, the picture started to become clear. He awoke with a start and arranged the cards in the pattern of his dream.
As a result of his extraordinary dream, Mendeleev cracked the problem. And this is what he came up with. A table with all the 63 elements he knew about, all laid out in one big array. What he'd basically done was to put them in order of increasing atomic weight, going across here and then across here and so on. But he'd also managed to get all the families together. Look here, the alkali metals, lithium, sodium, potassium, rubidium, cesium. These are the ones that react so violently with water. Then the alkaline earths, beryllium, magnesium, calcium, strontium, barium. And over on the other side, the halogens, fluorine, chlorine, bromine and iodine. He was so sure that he'd got it right, that he also made a really important discovery. Just look at these gaps.
Gaps.
Gaps where elements should have been, but none existed. So he made a prediction. He said, and he had the daring to say, that perhaps these are the elements we should look for.
There were several gaps. There was one between aluminium and indium, another between silicon and tin.
Scientists aren't usually hailed as geniuses when there are holes or question marks in their work. But in this case, those holes were crucial. Those holes were the things that everyone else had failed to spot, because they signified the positions of elements that hadn't yet been discovered.
He was the first person who spotted the missing pieces of the jigsaw puzzle when he left these gaps, and then was so bold as to predict the properties of the elements which hadn't been discovered yet. He was practically laughed out of scientific circles until 5 years later, when someone discovered what was to become gallium, which fitted perfectly in the gap that he'd left underneath aluminium.
And 15 years later, the next gap was filled with the discovery of germanium. By comparing the missing element with its neighbours, Mendeleev had accurately predicted its colour, melting point and atomic weight.
Well, it took 20 years, but elements like germanium and gallium were found, which then fit the periodic chart, enshrining the name of Mendeleev among the giants of science.
The periodic table can be used to make predictions still. If you like, it's a list of ingredients for the universe. It's a recipe book that tells you how you can mix things and what results you're going to get.
Curiously, Mendeleev wasn't alone. At almost exactly the same time, a German scientist called Julius Meyer came up with a very, very similar scheme. But Meyer is forgotten, Mendeleev is famous, because he made those bold predictions about elements that would be discovered in the future. In fact, he became so famous, they even named an element after him, Mendeleevium.
There are lots of differences between Mendeleev's original table and the one we use today. More than 40 extra elements have been discovered, and we now list them by atomic number, the number of protons in each atom, rather than by atomic mass. In Mendeleev's time, no one had proved that atoms even existed. Electrons, neutrons and protons were completely unknown.
Mendeleev had uncovered one layer in his quest for the nature of matter, but there were more secrets waiting to be discovered.
Scientists now think that most of the universe is made up of mysterious stuff called dark matter.
Maybe we have to throw the periodic chart out the window and realize that the 90% of the universe could be made out of something other than atoms. And perhaps somebody listening to this show may win the next Nobel Prize by determining what dark matter is really made of.
But if Mendeleev were alive today, there's one thing that would delight him. Remember gallium, that element he predicted should exist? For many years, no one could find much use for it. But recently it's been found that gallium compounds glow very brightly when tiny currents pass through them.
And this is where we find gallium today, in the latest form of video screen, the trademark of the information age. Thanks to Dmitri Mendeleev, we've come a long way since those ancient Greeks, with their earth, water, air, and fire, 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 fire. Earth, water, air, and cold fire.
That may be the end of that particular experiment.
Yes.
Takes me straight back more than 2,000 years to ancient Sicily, and a chap called Empedocles, who sat and gazed into his fire and thought about the world, and came to the conclusion it was made of just 4 elements: earth, air, fire, and water. He could see them all there in the fire. A piece of green wood going on dribbled sap. It was obviously the water.
Stars are made largely of hydrogen, but when hydrogen atoms are superheated, they fuse together to make heavier elements, from helium up to elements as heavy as iron.
Stars are like ovens. The longer you cook the elements of a star, the more elements you make. But our sun is not hot enough. It doesn't have enough energy to combine elements to create elements beyond iron. However, our bodies, of course.
What is the world made of? In trying to answer that question, philosophers and scientists for thousands of years, have been considering everything from the smallest particles in the universe to cataclysmic events happening billions of miles away.
This is where the commonest elements are created in stars, like our sun.
Are made out of elements like cobalt and nickel that are beyond iron. So we had a paradox. Where do we have enough energy, raw energy, to create the elements beyond iron? And the answer is supernovae. When stars explode, trillions of degrees are attained. Temperature is so hot that you can slam iron and different elements together to create uranium, to create plutonium, and all the other elements of the periodic chart. So when you look at your body, when you look at the elements around yourself, just realize that we are made out of stardust. We came from the stars.
It took centuries to discover those elements and sort them into a neat periodic table. But people have always been fascinated by what the world around them was made of.
Sitting here on the beach, gazing into the fire,